So now what will be the condition for maxima and minima? Now that we know in the intensity distribution pattern there are two separate patterns. Okay, there will be the mixture of two separate patterns, diffraction pattern and as well as the interference pattern. So we will have conditions for maxima and minima for diffraction effect also and for interference effect also. So first we will discuss the conditions for maxima and minima for diffraction effect. So diffraction effect, first we will consider the diffraction effect. So what is the condition for maxima? So the diffraction effect depends on the terms 4a0 square psi square alpha by alpha square, right? So again here there will be principal maxima. Okay, so the first condition is for the principal maximum. For principal maximum, you know, it occurs at the center of the screen where alpha is 0. Okay, so it will be, so limit alpha tends to 0, we know sin alpha by alpha equals to 1. I have already discussed this for the single slit. Okay, so there what will happen, that for the principal maximum we will have an intensity of 4a0 square. Okay, or you can say 4I0. Okay, so this is the condition for principal maximum. Then there will be secondary maximum, which will be same as the condition for the single slit, where alpha is plus minus 3 pi by 2 approximately. Okay, approximately plus minus 3 pi by 2 plus minus 5 pi by 2 plus minus 7 pi by 2, etc. Then we will have the condition for the minimum. So between the secondary maxima there will be minima. Okay, so which is again same, the conditions are same as the condition for the single slit. Okay, which is the minima intensity occurs where the intensity is 0. Okay, and for the secondary maximum we'll get the intensity of I1. Then for the second intensity for the second secondary maxima I2. Okay, then I3, in this way, in the decreasing manner. That is, the first secondary maximum will have the maximum intensity, but it will still be less than the principal maximum intensity. Then as the order of the secondary maximum increases, the intensity gradually decreases. Okay, so and at the minima points the intensity is 0. And what are the directions or position of the minima? Those are given by alpha equals to plus minus pi. It is similar to the condition for the single slit. Okay, alpha equals to plus minus pi, plus minus 2 pi, plus minus 3 pi, etc. Okay, so we can say that in general it is alpha equals to m pi. Okay, so for diffraction effect we have the condition for the principal maximum, which is alpha equals to 0 at the center. Then for alpha approximately equals to plus minus 3 pi by 2 plus minus 5 pi by 2 plus minus 7 pi by 2. In this manner we get the secondary maxima. Okay, and then we have condition for the minima, which is in general is given by alpha equals to m pi. That is, at alpha equals to plus minus pi, plus minus 2 pi and plus minus 3 pi, we get the minima points where intensity is 0. Okay, so this was for the diffraction effect. So now we have the interference effect, for which we will also get the condition for maxima and minima. That is interference, maxima and minima. So diffraction, interference effect. Next is the interference effect. So So the interference effect is given by the cos square beta term, right? Interference effect is given by the cos square beta term. So for the interference pattern, it will be the maximum intensity will be maximum when cos square beta equal to 1. Okay, so in interference pattern we will get interference maxima when this factor responsible for interference cos square beta is maximum, which is equal to 1. Okay, or we can say that cos beta equals to plus minus 1 or beta equals to p pi. Okay, where p equals to 0, plus minus 1, plus minus 2, plus minus 3, etc. which gives the following values of the p, which are 0, plus minus pi for p equals to plus minus 1, then plus minus 2 pi for p equals to plus minus 2, then plus minus 3 pi for p equals to plus minus 3, etc. So now if we put the value of beta, we have pi a plus b sin theta by lambda equals to p pi. Okay, because beta is equals to pi into a plus b sin theta by lambda, which gives us a plus b sin theta equals to p lambda. Okay, so if we put these values of p0, 1, 2, 3, 1, 2, 3, etc., then we can find the corresponding direction. That is, we can find the value of theta. Okay, if we put the values of p and the lambda and a plus b are known. Okay, so this is the condition interference. This was the condition for interference maxima. Okay, so this was the condition for interference maxima. So next we will find the condition for interference maxima. Okay, so for interference minima, sorry. So for interference minima, we will get the positions of interference minima when again the term responsible for interference is minimum, which is 0. Okay, so, or cos beta equals to 0, if cos square beta equals to 0, cos beta equals to 0, or beta will be 2p plus 1 into pi by 2. Okay, so again where p equals to 0, plus minus 1, plus minus 2, etc. Okay, so therefore if we put the value of beta, which is pi into a plus b sin theta by lambda equals to 2p plus 1 into pi by 2, it gives us a plus b sin theta equals to 2p plus 1 into lambda by 2. Okay, so similarly again if we put the values of p, we can find the positions of the interference minimum. So now what will be the intensity distribution curve for the double slit diffraction? Okay, so here we will get a diffraction pattern, another interference pattern, then there will be superposition of this diffraction and interference pattern, and we get the resultant pattern. Okay, so first let us draw the diffraction pattern. Okay, so this is the diffraction pattern. Okay, so here over here we are plotting alpha. Okay, so alpha equals to 0, suppose pi, then 2 pi in this way. Okay, so it will be similar as the single slit diffraction pattern. Okay, and the maximum intensity will be 4I0. Okay, 4 alpha A0 square. So it will be like this. and at pi the intensity is minimum. Okay, then around 3 pi by 2 the intensity is again maximum, and we get the first secondary maximum. Okay, in this way. Then in decreasing manner we get the next secondary maximum. Then on the other side also, this is minus pi and minus 2 pi, right? So again we get the first secondary maximum, then with decreasing in intensity we get the second secondary maximum. Okay, so this is the diffraction pattern, which is the sine square alpha by alpha square term. Okay, then we have the interference pattern. Okay, so this is pi, okay, minus pi, then 2 pi and minus 2 pi. Okay, so it should the same line. Okay, so here we will get the interference pattern. So you know how is the interference distribution pattern? It is like the, so here if we write the, this is the interference pattern, which is determined by the cos square beta term. So in this way, all the fringes have the equal width, like we know, but in the case of diffraction it is different widths have different width, different fringes have different width. So in this way. Okay, now if the two these two superpose, what we get? We get the resultant pattern. Okay, so we get the resultant pattern. So pi minus pi, then 2 pi and minus 2 pi. Okay, so we have got this envelope of the diffraction pattern. Okay, and within the diffraction pattern we will get the interference pattern. That is there will be this interference fringes. Okay, like this. So within the diffraction pattern we get to observe the interference fringes like this. Okay, so this is the resultant pattern. Okay, so which depends on this factor, both the factors sine square alpha by alpha square into cos square beta. Okay, so now we will discuss the missing order.